This video is about how to balance chemical equations. We're going to start with the skeleton equation. Sodium reacts with chlorine to produce sodium chloride. Now, the first thing that you do when taking a skeleton equation and writing the chemical reaction from it is you look for key terms. So in this, and we're looking for key terms that give us symbols to put into our chemical equation. So in this skeleton equation, I see the term reacts with, which indicates that I'm going to be putting a plus sign. I also see the term to produce, which indicates I'm going to be using an arrow. And the remaining terms are chemical symbols that I'm going to be including in my chemical equation. So taking my skeleton equation and writing it as a chemical equation instead, I end up with Na, because that's a symbol for sodium, plus, because that means reacts with, chlorine, which is Cl2, and Cl2, or chlorine, remember, is one of those diatomic molecules, so when it's by itself, it must be written with the subscript of 2. And then the arrow comes next because the term to produce, and then finally I have my product, sodium chloride, which the formula for that is NaCl, because the charge of sodium is +1 and the charge of chlorine is -1, and since those add up to 0, I don't need to add any extra subscripts. Now, one thing you may have noticed about taking these skeleton equations and turning them into chemical equations is that there aren't equal amounts of each element. So in the example that I have on the board, do you see how on either side of the arrow, if you look at the total amount of sodium, that's equal because there's one on the left and there's one on the right. But the chlorine, however, is not equal because there's 2 chlorines on the left and only 1 on the right. Well, when balancing equations, we need to make sure that our balanced equations, they obey the law of conservation of mass. And the law of conservation of mass says that mass, or matter for our case, is not created or destroyed, only changed from one form to another. Hopefully this is something that you remember from first semester of chemistry. So in order for our equations to obey the law of conservation of mass, or matter, we must balance them. And by balancing them, we are going to put coefficients, which are numbers that go in front of something else, into our equation. And the numbers that we're going to put in front are going to be on those, in the equation that I have written, the Na plus Cl2 produces NaCl. They are going to be on those lines that I put in front of NaCl2 and NaCl. So the coefficients are things that you would multiply those element symbols by in order to get equal amounts. Well, how do we go about doing this? Well, I have an order with which I like to make sure things are balanced, and it will work for you every single time you try this. So the order in which you check to see if things are balanced goes as follows. Start by looking for metals first, followed by nonmetals, then any polyatomic ions that remain together throughout the equation, and then finally, in this order, carbon, hydrogen, and save oxygen for the very end. So in the equation that I have written, sodium plus chlorine produces sodium chloride. Starting with metals, sodium is a metal, so check to see how many you have on each side. And the way you know how many you have is by looking at subscripts. And since both sodium symbols do not have a subscript after them, that means that there's one of each one, which means that sodium is balanced. Now looking at nonmetals, which in our case is chlorine, on the left there are 2 chlorines, and on the right there is only 1 because there is no subscript. So in order to balance it, I need to multiply the side with fewer chlorines by something in order to make equal amounts. Well, since I know I have 2 chlorines on the left and only 1 on the right, I know the common multiple between 2 and 1 is 2. And so in order to get 1 chlorine to be 2 chlorines, I need to multiply by 2. So that means I put that coefficient of 2 in front of NaCl. Now, just like any coefficient, if you were in a math class, it would distribute to everything in the term. Well, these coefficients in our equations in a chemical reaction do as well, which means that by putting that 2 in front of NaCl, I am now saying I have 2 sodiums and 2 chlorines on the right side of this equation. But I've already stated that I was balanced with sodiums, and by putting this 2 here, this means that I've now balanced the chlorine, but the sodium has become unbalanced. But that's okay, because I can always go back and I can multiply my other side of the equation by something to make the sodiums equal again. So in order to make it so I have equal amounts of sodium, I'm going to need 2 on each side, which means I'm going to need to multiply sodium on the left by 2 as well. And now looking at my equation, going back through and checking everything, I have 2 sodiums on the left, and I have 2 on the right side of the arrow. I have 2 chlorines on the left, and I have 2 chlorines on the right side of the arrow as well. And one other note to make is that I don't have a coefficient in front of the Cl2. That's okay, because in chemistry, when there's 1 of something, you really don't need to show that you're multiplying by 1. So having there be no coefficient in front of Cl2 indicates that you are multiplying by 1. Okay, let's look at one more example just to make sure you understand this. So this time our word equation says silver nitrate reacts with copper to produce silver and copper 2 nitrates. So looking through and coming up with all of my symbols, silver nitrate is one symbol I'm going to need, followed by reacts with, which will be a plus sign. Copper is another symbol, and then to produce, which will be my reaction arrow, and then followed by silver, which will be another symbol, and, which is another plus sign, and then copper 2 nitrate. So putting this skeleton equation into a chemical equation, I end up with AgNO3, because silver has a positive 1 charge and nitrate has a negative 1 charge, plus copper, which is just the symbol Cu, to produce silver, which is just the symbol Ag, and, which is plus, copper 2 nitrate, which means copper has a positive 2 charge, nitrate has a negative 1 charge, which means in order to get our charges to add up to 0, I need 2 nitrates to my 1 copper. So I end up with CuNO3 remembering to put NO3 in parentheses because you cannot change anything about the polyatomic ions. So in order to indicate that you have more than one of them, you must put an extra subscript outside of the parentheses. Now I again put the lines out in front of each of my symbols because what I am saying is that I am only going to be adding coefficients, or I should say placing coefficients in front of each of my terms. I cannot change anything about any of my chemical symbols once I have them written. So following the order in which I gave you to balance before, I'll look for metals first. So metals in this case, I have silver. Silver is a metal, and I see that I have 1 on the left and 1 on the right. So silver is already balanced. And I need to check all of my other elements to see if I have any other metals, and I notice I do because I see copper. There's 1 copper on the left, and there's also 1 copper on the right. So copper is already balanced. Now, I can look through at my nonmetals individually, or I can notice that I have a polyatomic ion called nitrate. The NO3 remains intact throughout the chemical reaction. So there's a nitrate on the left side of the arrow, and there's a nitrate on the right side of the arrow. So I can balance that as one thing, or I can break it apart and balance it as nitrogen and oxygen separately. Just remember, save oxygen for the very, very end. So if I keep it together as a polyatomic ion, since there are no parentheses around it on the left side of the arrow, that means that I have 1 of them. Since there is parentheses around the right side, or around it on the right side, and there's a 2 outside, that means I have 2 nitrates on the right. And so to get a common multiple between 1 and 2, I know I need to multiply the left side by 2 in order to make both of them equal to 2. But in doing so, I'm now saying that I have 2 silvers and 2 nitrates, which means I need to go back and make sure that my silver is balanced again. And to do this, I need to multiply the silver on the right side of the reaction arrow by 2 as well. And now just to go back and double check everything, I have 2 silvers on the left and 2 on the right. I have 2 nitrates on the left and 2 on the right. And I have 1 copper on each side of my arrow, so I have a balanced equation.